Hello, welcome back to this lesson or this video, the second video on vector product. So I have deliberately not erased this part so that we can still make reference to this product. Okay, so now I want us to use the algebra method of multiplying two vectors, vectors to get the vector product. Okay, so we're looking at the algebra method. So this one simply deals with, simply deals with the usual expansion, right? The usual expansion. Remember, we have a factorization. We also have expansion, isn't it? Okay. So, like for example, if we have, let's say we have a plus b, and then we also have, let's say, c plus d, right? So what do we do in this case? How do we multiply these? We're going to multiply a by c, that is going to be ac, and then a by d, that's going to be ad. Then from there we multiply b by c, that's going to be bc, and then b by d, that's going to be bd. All right. So that's a simple example that I can give for us to understand what this method is all about, right? So this algebra method also literally just involves us expanding the products that we have, that we've been given. I think it's a similar case as what we had under the product. Okay, so let's go ahead and look at two vectors. So let's say we say, given that A, which is equal to AXI plus AYJ plus AZK, right? And what? B is equal to BXI. They are just any two vectors, right? Plus BYJ plus BZK. Okay? Are any two vectors. Okay. Find what? A. We want to find A multiplied by B, then B, we want to also find what? Want to find the magnitude of A multiplied by B. All right. Now, this is going to be in your separate time. So we're going to find A multiplied by B, and then in your separate time, you should also calculate, or rather find B multiplied by A. I want you to do the same thing that we're going to do with this, but you reverse them so that we see what we're going to get, and so that you notice that they're basically going to be the exact opposite as. So this is going to be in your spare time after the lesson. Okay. Then part C, the direction of A multiplied by B. Okay, the direction of A multiplied by B. Then D, the angle theta between A and B. Okay, so this is what I want us to get. That's what we need to find, right? That's what we need to find. So now, here we are not using specific values, all right? And the reason is simple. I want you guys to know what exactly is involved, what exactly to do, so that even when you have specific values, it's not going to be something difficult for you. you're going to basically just apply the same concepts that we have here on dealing with such kind of questions. Okay, so let's try to do that in the next 10 to 15 minutes, and then we'll be done. We'll look at the other method, the matrix method, in the next lesson later on. Okay, so let's have that, right? Let's have that. So what are we getting? We have, remember, we want to find A multiplied by B. Now we know that A was what? AXI plus AYJ plus AZK. All right? Multiplied by B was BXI plus BYJ plus BZK. Okay? That's what we have, right? That's what we have. So now, what next, right? What next? So remember, we're talking about the algebra method where we just need to expand. So in other words, we're going to start with AXI, and then we multiply it with each of these in here. Like that, right? So I'm going to multiply AXI by each of those, and then from there we're going to come to what? AY and multiply it with each of these. Then we come to AZ and multiply it with each of these, and then we'll be done. Okay, so this is going to be equal to AXI by BXI. So this is going to give us AX, okay, AX BX, right? Then I multiplied by I, okay? I multiplied by I. Then plus, what are we going to have? Plus what? AXI by BYJ. So that is going to be AX BY I multiplied by J. Okay, I multiplied by J. Then from there we have AX I multiplied by BZK. AXI multiplied by BZK, that is going to be AX BZ I dot multiplied by K. All right. So we are done with the first one, which is AX. We're done with that, right? And then let's go to the next one. The next one, what do? We are multiplying AY with each of these. Sorry, that marker is not all that clear. I hope it's showing something. Okay, so that's what we're going to do next. So we're going to say plus AYJ multiplied by BXI. So that is AY BX J multiplied by I. All right, plus we go to which one? AYJ multiplied by BYJ. So that is going to be AY BYJ multiplied by J. Okay. Then from there, we go to AY multiplied by AYJ multiplied by BZK. So that is going to be plus AY BZJ multiplied by K. Okay. Plus. So we are done with AY. Then we come to the last one. We come to the last one, which is what? Which is AZ. Okay. We come to the last one, which is AZ. So AZ, we multiply it with each of these. All right, like that. So what we're going to get now is going to be AZK multiplied by BXI. So that is going to be AZ BX multiplied by I. Then plus AZK multiplied by BYJ, so that is going to be AZ BY. Then we have what? We have k multiplied by j. Plus, lastly, we have what? We have azk by bzk. Az bz, then k multiplied by k. Okay. Now, we finished multiplying, or rather expanding, right? We finished expanding. Now, remember, we have these values, right? And then we also said that I multiplied by I is the same as, is equal to j multiplied by j, which is equal to k multiplied by k, which is equal to what? 0. Okay. So let's check out. Wherever we have the same values, wherever we have I and I being multiplied, we should know that the answer there is what? 0. Okay. So we have the first part here. This is going to be a 0, right? And then which one else? Here as well, we're going to have a 0, right? And then here we are also going to have what? A 0. Okay. We're going to have zeros there. And then we know that if we multiply 0 by anything, the answer is going to be what? To be 0. So in other words, these ones, all these are going to be cancelled. Okay, these are going to be cancelled because they are going to give us zeros. Okay, then what next? Let's now start collecting the like terms. Okay, we collect the like terms. For lack of better terms, we get what? The other thing that we do now, okay, the other thing that we do now is we apply this. So we've applied this rule here, showing that if we're multiplying parallel vectors, we're going to get a 0. And then we apply the rule of perpendicular vectors. What are we going to get? So let's look at this part. So we already know that this part is gone. So this is going to be, we have this part which is ax, right? Ax by, right? Ax dy, and then we have I multiplied by j. So where do we have I by j? Here. I by j, that is going to give us what? K. Okay. So this I by j is being replaced. This I by j, let me use green. Okay. So this part, this whole thing here is being replaced by, where if I put a green mark? Okay. So this whole I by j here is being replaced by what? By k. Okay. Being replaced by k because that's what we can see there. So I'm going to put k. Let me use green. Okay. Then what next? We now go to which one? We say plus, we have ax bz I by k, I by k. So we have I by k here, right? You have I by k, which is giving us what? Negative j, all right? It's going to give us negative j. So this is now going to be ax bz, then negative j. Okay, negative j. Then plus what? Plus. So we are done in the first line. We come to the second line. In the first line, we have ay bx j by. So we have ay bx. All right. Then what? J by I. What is j by I? What do we have on j by I? J by I. All right. So j by I, we can see that it's what? Negative k. Okay. J by I is negative k. So I'm going to write that also in brackets, negative k. And then we say plus. This one is gone. Then we have ay bz. Okay. ay bz. Okay. ay bz j by k. What is j by k? J by k is right here. which is I. So I'm going to write it in green as well. We have I. Okay. Then we proceed. Plus, which one else? So we're done in the first line. The second line as well. Let's come to the third line. So we have AZ BX, AZ BX, right? AZ BX, K by I. What is K by I? K by I is right here, so that is going to give us J. That is J. Okay. Then plus what? We come to this one, AZBY. All right, AZBY, this is going to be what? K by J. K by J is right there at the end. K by J is negative I. Okay, negative I. Like that. Now, let's try to simplify it a little further, right? Let's try to simplify it a bit more. So this is going to be AX BY K, all right? And then we can see that since there's a negative, this positive and the negative can multiply, and then rather this negative can come out and multiply with the positive there, so it's going to be minus AX BZ J. Okay. Similarly, this negative and that positive can multiply and become negative, so it's going to be minus AY BX, right? BX. Then what? Then we have K plus, here we have AY, all right? We have AY BZ I. The I will leave it as it is because it's positive. Then plus, here we have AZ BX J. Then this negative and that positive, they can multiply to become minus AZ BY, okay, I. Okay. Now from there we collect the like terms. We get those with I and the ones with I. We get the ones with J and the ones with J. The ones with K and the ones with K. We collect the like terms. Okay. So I'm going to erase on top. The best favor you can do yourself is after this lesson, you go through what we're just from doing, because this can be confusing if you're not careful. All right. So the best thing that you can do is to go through that. So we want to collect the like terms. We get the I and the I. So we're going to get the first one with I here. Okay, we're going to get this one and that one. So this is going to be equal to AY BZ minus what? This is, okay. So let me put the I so that I don't confuse you. I and then minus AZ BY I. Okay, so we've collected those like terms. Then we go to the next one. The next one with J and it's positive. So I'm going to get which one? We're going to get we have this one here. Okay, let me circle it. That one is as J and it's positive, so we're going to say plus AZ BX J. Okay, and then the next one with J is this one. Together with each sign which is negative, we're going to say minus what? AX BZ J. All right, then plus. We go for the one with K and it's positive, right? So I'm going to get this one here. I'm going to tick on it. So I'm going to have plus what? AX BY K. Then and lastly we have this one. So together with each sign, we're going to say minus ay bx k. Okay. Now, we can factorize at each of these points. Okay. At this point, we can factorize. At this point, we can also factorize. And also at this point, we can what? We can factorize. Because you can see that I is common, j is common, and k is common there. So this is now going to give us, it's going to give us what? I can erase this part now. Okay. So this is now going to give us ay bz minus az by I, okay, plus what? Here we have az bx minus ax bz j. Okay. Then lastly we have plus ax by minus what? Ay bx k. Okay, so this is going to be the answer, right? This is going to be the answer, and it can be expressed as, okay, it's going to be a new vector which can be expressed. So if we say let a multiplied by b equal to c, then what we're saying is that c, this vector c, okay, and the vector c is equal to this. It's going to be equal to ay bz minus az by all right, I plus az bx minus ax bz j plus ax by minus ay bx k. Now, there's nothing to memorize here. You're not memorizing anything. You don't need to memorize anything. Okay. So this implies that C, the vector C is Cxi plus okay. So let's continue where we ended with this. We're trying to solve that. So I was saying that we're now trying to represent each of these as a new vector called vector C. So Cx is that, Cy is that, and Cz is simply that. Okay. So now from there we can even now calculate the what? We can calculate the magnitude actually and say the magnitude of vector C is going to be equal to the root of Cx squared plus Cy squared plus Cz squared. Okay. That would be the magnitude of vector C. Then from there we need to also find what? We need to find the angle between vector A and vector B. Okay, we need to find the angle between vector A and vector B. So remember we said that the magnitude of A by B, all right, is equal to magnitude of A multiplied by magnitude of B, then sine theta, right? So we already have the magnitude of A by B, which is C. Okay, this whole thing here is vector C. Should remember that. Okay, so all we need to now do is find the magnitude of B and the magnitude of A and the magnitude of B, and then put them together into this formula. So we already know that magnitude of C, which is equal to magnitude of A by B, is equal to what? Cx squared plus cy squared plus cz squared, right? Plus cz squared. Then the magnitude of A is obviously equal to ax squared plus ay squared plus az squared. And the magnitude of B is going to be equal to the magnitude b x squared plus b y squared plus bz squared. Okay, so those are the magnitudes. Then we put them into that formula, into that equation. So we know what this is. So this is going to be cx squared, root of cx squared plus cy squared plus cz squared equal to, is going to be equal to root of ax squared plus ay squared plus az squared multiplied by root of bx squared plus by squared plus bz squared. Then sine theta. Okay, sine theta. So we can divide both sides. Okay, we can divide both sides by this. In other words, to make sine theta subject of the formula. So we divide both sides. We can simplify it further anyway, but we're not going to go that direction. By the way, if we had definite values, we would not be dealing with all these lengthy formulas. Okay, so we divide both sides by this. This is going to be equal to ax squared plus ay squared plus az squared, then multiplied by bx squared plus by squared plus bz squared, right? And this side as well, we multiply with the same, which is ax squared plus ay squared plus az squared, and then multiplied by bx squared plus by squared plus bz squared. So this and that will cancel, that with that will cancel, then you remain with sine theta is equal to the root of cx squared plus cy squared plus cz squared. Then all over ax, root of ax squared plus ay squared plus az squared multiplied by root of bx squared plus by squared plus bz squared. Okay, now we want to get sine theta. We want to get theta, which is the angle we are looking for between the two vectors. So therefore, theta is now going to be equal to sine inverse. Okay, sine inverse of what? Of all this. Okay, root of cx squared plus cy squared plus cz squared, then all over root of ax squared plus ay squared plus az squared multiplied by root of bx squared plus by squared plus bz squared. Okay, so that would be the answer in a case if we had definite values. Okay, if we had definite values, that would be our final answer. That would be our final answer, right? So we would have some angle as the angle between those two vectors. Okay, so we're going to end here, and then we're going to continue next time. We're going to look at the matrix method, where we calculate the determinant of the matrix. We make those into a 3x3 matrix, and then we go ahead to find the determinant. So that's what we're going to look at next time. So bye bye for now, and see you next time.